Hello and welcome to the LEGO Robotics exhibition presented by the FOST Discovery Center, an introduction to the world of robotics and programming. LEGO Mindstorms is a series of kits that contain software and hardware to create small, customizable, programmable robots. They include an intelligent brick computer that controls the system, a set of modular sensors and motors, and various LEGO parts to create the mechanical systems. There are various types of LEGO Mindstorms, but today we'll be focusing on the EV3 LEGO Mindstorms. Within the EV3 generation, there are two types of kits: home and education. These lesson plans are designed to be used with the EV3 education kit, containing an EV3 brick, two touch sensors, an ultrasonic sensor, and a color sensor. However, modifications can be made to the design of the robot and the sensors used in projects to accommodate for different kits. If necessary, volunteers may skip the lessons involving sensors they don't have. This will affect the content covered and the timing. Alternatively, all EV3 sensors can be purchased online. Programming a Mindstorms robot is done via a flowchart language called RoboLab, based on a language called LabVIEW. The programming structure simulates a flowchart design icon by icon and allows the robot to perform different operations autonomously. This graphical approach allows novice programmers to build programs by dragging and dropping virtual representations of various operations such as moving, braking, or rotating an arm attached to a motor. The blocks are then connected via a virtual wire. The program created via the graphical sequence of operations is then uploaded to the brick and the robot will perform the commands as programmed. In addition to the actual kit, using Mindstorms requires a computer or tablet on which the code is created before being uploaded to the robot. Software for a computer can be downloaded from the LEGO website, and a software app for a tablet can be downloaded via the tablet's app store. This is the software, the interface. You have different instructions here. This is obviously just for the core set. You see model instructions. We'll have different robots here: gyro boy, color sorter, puppies, and so on. Now we want to go to File, and you want to start a new project, start a new program, and Open. Now this is a completely blank project, completely blank program, and what you want to do is just to move the robot. So you notice that there are different actions placed at the bottom here with different colors: action, flow control, sensor, data operations, advanced, and my blocks. And within action you have medium motor, which operates your medium motor; large motor, which operates your large motor; move steering, move tank, display, sound, and brick data slide. So now to move our robot in a straight line, we just want to click on move steering and drag that over there. Now you notice that on the green bar it has ports B and C. That's where our medium motors are connected. So this instruction here controls ports B and C. Now within this instruction here for port B and C, you have different instructions. We can click on off, which would then stop our robot; on, which would move our robot continuously; on for seconds, depending on however many seconds you want it to move for; on degrees; and on rotations. So we're going to use rotations. So now we're moving our robot based on rotations, how many cycles of the wheel. So let's just click on 2 just for our robot to move. Now our robot is going to move for 2 rotations in a straight line at a speed of 50% of the robot's speed. Now, if we click on this 0 and we move this cursor to the right, notice what happens to the arrow. It moves to the right. That's a positive number. Now, if you go back to 0, let's go straight. And if you go to the left, that means a negative number, it turns left. Now, that's one way of steering our robot. We're going back to 0 because you want a robot to move straight. So now, our robot's going to move for 2 rotations in a straight line at a speed of 50. Let's try that out. Now that that's done, we want to move our robot in a square. So we'd have to have another instruction here for our robot to turn, because it's already moving straight, for our robot to turn right, and for that to continue until it completes a square. So what we're going to do is add another move steering instruction there, drag and drop. Now, as I said, the 0 here is for the direction of the robot. So we want to put it on, say, 50, just to test it out, to test how the turn is. Put on 50 for 1 rotation at a speed of, let's say, 30. And this controls port B and C. And right now we want our robot to move straight and to turn right. We want to put these 2 instructions in a loop so that it continues until it completes a square. So what we do is move down to flow control, and you notice that there's a loop in here. Now we click on the loop and we drag it right there in the beginning. Drop it in there, and you click on this whole 2 instructions, the move forward and turning right, and we drag it inside the loop. Now within this loop you have this instruction there which has an unlimited number of times, but we want it to happen 4 times. So we're just going to click on the count, and we just want it to happen 4 times to complete a square. Right. So right now our instruction looks like this. It moves straight for 2 rotations at a speed of 50, turns right, and then it's going to continue this instruction until it finishes the square. Now let's try that out. Notice how I gave you a different robot. Right. Sure. What? Click on it. It's running now. What is it next? Okay, now it's running. So we have to paste it again, and then let's test it. I would suggest to bring it closer. Equals.